Hello and welcome. In this video I'll be talking about the standard normal distribution. So a normal distribution is one that follows this bell-shaped distribution, and we know that this is going to be centered at the mean, and at these inflection points we're going to have or we will find inflection points at the mean plus 1 standard deviation and the mean minus 1 standard deviation. And so in this video, though, I'm going to be talking about a particular normal distribution, one called the standard normal distribution. And for this distribution, the mean is 0, and each standard deviation, or a standard deviation, is 1 unit. So this would be the mean plus 1, the mean plus 2, and the mean plus 3. But the mean is 0, so this is just going to be 1, 2, and 3, and this will be -1, -2, and -3. So when I'm talking about the standard normal distribution, I'll use z for my random variable, so I can say that z follows a normal distribution that's centered at 0 with a standard deviation of 1. And everything that we know about any other normal distribution certainly applies here. So, for instance, the empirical rule. So I know that, for instance, actually I'm going to just move down and draw a new curve here. So here's the center at 0, 1, 2, and 3 standard deviations. 1, 2, and 3, so it's -1, -2, and -3. Okay, so the area that's under this curve between -1 and +1, so under the curve and above the horizontal axis and between these two values, that is, according to the empirical rule, that's 68% of our area, and so it has an area of 0.68. And so that's from here to here. Now, this is symmetric, so half of our area is to the right of center and half of our area is to the left. So I can take this value of 68%, I can also split that and say that the area that just lies between 0 and 1, that's 0.34. So that's the first percentage of the empirical rule. I could also go 2 standard deviations, so from here to here. That's 95% of my data, or that has an area of 0.95. So that's the area that's under the curve, but between these two values, so that's this area, that's 0.95. And once again, you could just look at this 1/2 of that, so that would be 0.475. And then finally, if we go from -3 all the way to +3 and look at the area that's under the curve but above that region, that's 99.7%, or has an area of 0.997. And you could split that in two as well and just look at this half, which would be 0.49 85? Yeah. So I'll just write that here, 0.4985. Okay. And you could keep going finding other percentages here. If this is 0.34 between here and here, then from here over must be 0.16, because these two values have to add up to 50. Let's see, if this is 0.475, then from here over has to be 0.025, because those have to add up to 50. So there are other percentages that you can calculate, just based on the 3 standard percentages from the empirical rule. So if we want to answer a question like, what's the probability that our random variable z takes on a value greater than 1? So I would look at my standard normal distribution and think about, well, 1 is over here. Greater than 1 means to the right. And so here's +1. So what's the area that's to the right? Well, looking at my guide here, I know that it's 0.34 between 0 and 1, and as I mentioned before, it's 0.5 if I look at everything to the right of 0, and so that's how we got this 0.16. So this would be 0.16. That's the area that's to the right of 1, or it's the probability of that a z, our random variable z would take on a value greater than 1. I could also ask the question, what's the probability that z would take on a value, less than -2? So in this case, when I'm considering the area that's in question here, this is -1, -2, and there would be -3. Less than -2 would be to the left of -2, so I'm looking for the area that's under the curve and to the left of -2. And so going back up to my picture here, I said that to the right of +2 was 0.025, and this is symmetric, so that also means that to the left of -2 is 0.025. So this is 0.025. Let's see. Another question. You might ask, what's the probability that z would take on a value in between two amounts? So maybe in between -1 and +2. And so in that case, if we're thinking about, like, here's 0, there's -1, there's +1 and +2, I'm looking for this area. So there's -1, there's +2. And I want to just break this up into pieces. So I know that just here, that has an area of 0.34. And because, again, it's symmetric, and just where I pointed out that it's 0.34 between 0 and +1, it's also 0.34 between -1 and 0. Together, those add up to the 68%. So 0.34, and then if I look at just between 0 and 2, that's half of 95, so 0.475. Okay, so I add those two together, 0.34 and 0.475. I'll have 5, 1, and 0.815. So that's nice. We can just do a lot with just the values from the empirical rule. But what if we get a question such as, what's the probability that we would get a z-score maybe greater than 1.2? So remember that a z-score is a continuous random variable, or the random variable z is a continuous random variable, so it can take on the value of any real number, and so certainly 1.2, that's valid, and but that's not one of the multiples of our standard deviation that we'll find from the empirical rule. So for this, we're going to use our calculator. I'm just going to grab mine, and I want to show you a function that we use. So we're going to be using the normal CDF function. To access that, you'll start by hitting the second key and then variables so that we can access this distribution menu. And option number 2 is normal CDF, so hit enter. Now you may have prompts depending on how new your calculator is. I do not. If you have prompts, you will, this is a little bit easier, but for the normal CDF function, the information that your calculator needs is a lower bound, an upper bound, the mean, and the standard deviation. Now, when we're talking about z-scores in the standard normal distribution, the mean is always 0 and the standard deviation was 1. So what about this lower bound and upper bound? So a key here is to know, recall, that this distribution, our standard normal distribution, goes on and on forever in both directions. This curve gets closer and closer to our horizontal axis, but it never actually touches it, so it goes down to negative infinity up to positive infinity. The issue with our calculator is there's not a button for infinity or negative infinity. So we have to kind of fake it. And so my recommendation is if you need a value to substitute for infinity, you just choose a really big number, like 10 to the 99th power. Or if we need a really large negative number, I'll use negative 10 to the 99th power. Okay, so let's back to our question. The probability that z is greater than 1.2. So I'm thinking about somewhere over here is 1.2, and I want the area under the curve to the right of that. So when I'm looking from left to right, the lower bound on the shaded area is 1.2, and the upper bound, well, that goes on forever. So it's infinity. So I'm going to use 10 to the 99th power, and then 0 and 1. So I'll use 1.2, comma, 10 raised to the 99th power, comma, 0, comma, 1. And again, if you have prompts, it's a little bit easier. You won't have to use a comma-separated list. You can just enter those values, but you would hit paste. I'm hitting enter. But that is about 11.5%, 0.115. So the area is 0.115. There's a probability of getting a z-score greater than 1.2. So I'm going to stop for now. In the next video, I'll give you some more examples using your calculator to calculate areas under the curve, or if you prefer, probabilities that are represented by areas under the curve.